Hi, this is Mrs. Clark, and welcome to my video on geometric relationships. You're going to make sure you cut this page in half if you have not done so already. So you should have this side, and then you should have this side, and you should have this little piece of paper. So if you don't have all three things, go ahead and grab them now, pause your video, and come back. Okay, so geometric relationships, we're going to start by talking about how are some of these things related to each other. And so that's what relationships comes from. The geometric comes from geometric figures. And so we're going to be looking at how are points related to each other, how are lines related to each other, how are planes related to each other. So first we're going to fill in the box here. Blank will always define a line. So it only takes 2 points to make a line. Some lines have more than 2 points, but you can have at minimum 2 points and then you have a line. When there's 3 or more points that lie on the same line, we call them collinear. So the word co means both or together, and then you see the word line in linear. So if you look here at this diagram, we need 3 things that are collinear, so 3 points that are lying together on the same line. If I look, A and F and B are all connected, so those 3 points are all collinear. I can line up a ruler and they all get connected. If I look at any other 3 points that are not collinear, I want to know that 3 that I couldn't line up with a line. So maybe F and G and H would not all line up in a straight line on a ruler. So those are not collinear. For this next part, blank that form a triangle will always define a plane. And that's 3 points. 3 points that form a triangle will always define a plane. When 3 or more points that are not collinear, so not in a straight line, lie on the same plane, they are called coplanar. So here's an example of a plane going up and down and a different plane going side to side. So points that are coplanar are this B, C, and E that are all on the same plane. But things that are not coplanar would be like B, C, and A, because they're not on the same plane. All right, so for the second page, you need this piece of paper and this. What you're going to do is we're going to cut these apart. So pause the video while I'm showing you. I'm going to cut them apart so that you've got the 3 terms at the top, and then you have the 3 diagrams separate. So you want these 3 and these 3, and then you're going to read through the descriptions and determine which words go up here and which diagrams go here. So pause the video, arrange them how you think they go, and then come back for an explanation. Okay, the first one. 2 lines that remain the same distance apart at all times and never intersect. So those are parallel lines. So parallel lines are 2 lines that remain the same distance apart and they never intersect. And so a picture of parallel lines would be these 2. You may have to trim them a little to fit in the boxes. I'm going to put this one sideways. I'll cut them in a second. All right. So we're going to cut those and glue them down. Okay, one thing that we want to mark on here is if we're looking at this picture of parallel lines, we need to put a marking on them that shows that they're parallel. So what that usually looks like is either a single arrow or a set of arrows, like on the actual line. So I'm going to put double arrows on this line, and I'm going to put double arrows on this line. And those markings are what a diagram would tell you if they wanted you to know that they're parallel. If you look down here at the symbols, you see line AB, and then this little 2 vertical lines, and then CD, line CD. This symbol is the symbol for parallel. So if you're writing it in symbol form, it looks like this. If you're marking it on a diagram, it looks like that. So the next one is two lines that intersect and form right angles, and then we have lines that meet or cross each other. So what I have left, and I trimmed these down really close to the diagram so we could see them, is these two. So both of them are crossing each other, but right angles mean 90 degrees, so that would be this one. So these are going to go here, and then these ones go here. And so what's the difference between these two? These ones cross at a 90-degree angle, and these ones just cross. So the words I have left are intersecting and perpendicular. And so perpendicular lines are going to be the ones that cross at 90-degree angles, and intersecting lines just means that they cross, and they don't have to cross at a specific angle. So let's pause and glue those down. All right, so we want to mark the diagrams accordingly. If they're forming right angles, so that means a 90-degree angle, we want to mark that on this diagram to show that these are perpendicular. So that means we're going to put a little box between NM and PQ. It doesn't matter which of the four sections you put it in, but that means that's a 90-degree angle, and that mark tells you that these lines are perpendicular. It can go in any of the angles here, and if that's 90 degrees, they're all 90 degrees. Down here, the perpendicular symbol is this upside down T. And if you think of it as a line coming down and intersecting this horizontal line, it's making 90-degree angles on both sides. So this is perpendicular. If I'm looking at intersecting, there's no way to mark that they're intersecting. We can just see that they're intersecting because they have this point in the middle where they cross. And there's no specific symbol for intersecting. So you can tell that something is intersecting if they have a point of intersection. But we can't tell if that intersection is special or not unless it's marked with a 90-degree. If it's not marked, we just know they're intersecting and that's it. So perpendicular is a special form of this one. So lines are either parallel, they cross at some angle, or they cross specifically at 90-degree angle. If you have a pair of lines, they're always going to be one of those three things. So go ahead and glue that in after your geometric relationships page. Thanks for watching.